Everyone, it's been a while since I've done a video for you, so I'm going to talk a little bit about a certain part of the geology of the Upper Peninsula of Michigan, and of course, it's going to be about the Precambrian. But first, just give you a little background. I gave you our bearings here. This is from the book I just showed you the cover of. Obviously, I'm not going to show you the whole book. That would defeat the purpose of having a book. But here, let's just get our bearings first. Here, we're looking at some major iron belts in the Midwest around Lake Superior. This here's the Huronian supergroup. You can see the Great Lakes, the modern Great Lakes. And basically, this is an old continental margin. We're going to go over here to the Marquette area. This is the Upper Peninsula of Michigan here. So we come here a little bit and we can see some things. This has to do with the bedrock geology. This right here is covered by Phanerozoic rocks, so Cambrian and younger essentially here, to exclude the Quaternary glacial deposits. So that's basically the eastern part of the Upper Peninsula. And for those of you that have never been here, this is also the flattest, swampiest part of the thing is over here. This red line is about the limit of the Michigan Basin. Now over here, what we have in gray is we have the mid-continent rift. This is Mesoproterozoic, about 1.1 billion years old. And we have some other sediments here too, Jacobsville, which is also Precambrian, but we're going to focus on this here, the stuff that's colored specifically right over here. These are what we call metamorphic nodes. Basically, they're zones of metamorphism from highest to lowest. Here's the color scheme. You can see this is the highest in what's called the Republic Trough. We're going to be in a chlorite, low metamorphic zone facies right over here. So we're going to go to Marquette now because I want to show you some things. Here's a map of the western half of the Upper Peninsula. And these are the stops that appear in the book. As you can see, Marquette has an inset because there were so many sites in there. And if you look at the next page, you'll see that there's only a few bedrock spots over here, and over here there's a lot. This is where you start to see a lot of topography, and up here's the mid-continent rift. This is older than that right here, and that's what we're going to go to in a second here. We're going to zoom in right here. So here on page 178, you can see a basic layout map of Marquette, which is the largest city in the Upper Peninsula. And you can see this is Lake Superior. This is one of the very few places in the world where you can find almost 3 billion years of geologic history within city limits. And these are the stops that are in this here. So let's take a quick look at it. When I do these books, if you had this in your hand, this would be the page to your left. I always do it this way. I put the GPS here because we have smartphones. You can just type this in and it'll drop you right there. So you don't need to go from point A to B to C in my guidebooks. So that's this, and this is a description of the geology, and on the next page are pictures. That's what I have here just to show you that. And I'm not going to go through every stop, but I am going to show you some of the stops. Let's move on to Tourist Park Falls. Technically, this is Campo Creek gneiss with chunks of the Mona Formation in it. This is old stuff. It's really old. So, as you can see here, we have some dates. The Mona's around 2.56 billion. And it's older than the Campo Creek by about 100 to 400 million years. We don't really know. Campo Creek gneiss is sort of just a waste bin name for the Archean in the area. No one's really delineated these rocks that much, and it's quite possible the Mona is actually older than this too. So that's just where I'm at right now with it. So the Campo Creek's barely Archean. It's late Archean, and there are other plutons in it and whatnot that have never been divided out. But here you see inclusions of the Mona in the Campo Creek, and that's what this is showing here. So this is a schist mainly, and it outcrops in other places, and migmatite of the Campo Creek gneiss. Technically, we had some melting. A migmatite is a special type of metamorphic igneous rock, if you will. Some people want to put it in its own class with igneous, sedimentary, and metamorphic. I don't think we need to take it that far. But it's where stuff has been metamorphosed to the point where some melting has occurred, but the entire rock hasn't melted. If the entire rock melts and then recrystallizes, you once again have an igneous rock. You don't have a migmatite. This here is the largest known float copper nugget, which I believe is found on the Keweenaw. This is here for historical purposes. In the first edition of this book, this thing still sat in the park in Presque Isle. Now, you can see in here, this is the red. This is the phone number. They tried to save it. They tried to raise money for it. They didn't make the money. So, as far as I am aware, it sits in China right now. A collector purchased it, and it was in a show in China. I know that for sure, but I can't find a trail after that. So I'm assuming it's still there. But here's some pictures of it. And then remember, this is a copper nugget. This isn't a rock with disseminated copper or copper ore spread throughout. This is a copper nugget. Ah, that's pretty big looking, but how big is it? I'm 5'11". I'm a bit chunky these days, but I didn't used to always be that way. Remember, I'm 5'11". That's me, maybe about 10 years ago. See how massive this thing is? Yep, June 13th, 2013. So almost 10 years ago. This thing was huge. And you can see it had glacial striations on it and stuff like that. And it's gone. It's not there anymore. They did replace it with a little piece of float copper and a new sign, but nothing nearly this big. I don't even think it's that big of a piece, really. So, yeah, it was good while it lasted, I guess. Now, you also go to Little Presque Isle, other places. You see what we think is the Jacobsville, which is also Precambrian, but it's Neoproterozoic. We think about 980 to 950 million years old. There was a paper that came out early last year that tried to lock it down and put it in that time frame, although it could be younger. Now, here we see unaltered peridotite. For a long time, basically, there was an argument which is older, the Jacobsville or this. And I've studied both of these, and I actually tried to date this last year. We didn't get any zircons or betulite out of it. And others have tried this too, and no one's to successfully do this. I might try again, but anyway, I digress. Here's the contact. This was not always exposed. This is a relatively new exposure that's maybe a few decades old. Now, some of the old timers sat there and described chunks of the peridotite in the sandstone. I've never seen them. I've failed to find them anywhere on the island, and they're not here. But what is here is sills of serpentinized peridotite, which indicates that this intrudes this. And we know this is Neoproterozoic, so this is at least Neoproterozoic, if not younger. This stuff is hard to date. There's a couple of these throughout the Upper Peninsula. One called Yellow Dog has been successfully dated, and it's about 900 million years old, if memory serves. It too is Neoproterozoic. And peridotites are ultramafic rocks. A lot of people thought this was Archean, so we're talking older than 2.5 billion years old. But they're probably all related, so the Yellow Dog is a guide. It's probably Neoproterozoic as well. Maybe someday we'll get the zircons from it that we're looking for. And here you see some conglomerate within the Jacobsville. I am not so sure that this is the Jacobsville either, but we'll go with it as being the Jacobsville because that's what it seems to be. And the sills of serpentized peridotite, there does seem to be some later hydrothermal activity after this was intruded. So these sills, this isn't that serpentitized, or that serpentinized as the intrusions into the Jacobsville are. And there's other places where you'll see the green serpentitized, the green altered peridotite along the contact, which indicates that this might have been encouraged by later hydrothermal activity or a secondary sort of magmatic event or later magmatic event that sort of just skirted the outside of this shortly after this cooled. Those are all talks for other times. It's just all these problems that need to be worked out. See, we don't know everything. We don't even think we know everything. But let me move on. Let's get into the Mesnard Formation. This is Huronian in age and equivalent to the Lorraine Formation in Ontario and the Sturgeon Formation further to the west in the Upper Peninsula. So this is circa 2.35 billion years old, something like that, I believe. So it's not Archean, it's Paleoproterozoic. And along the trails, a lot of times you'll see it's a white quartzite. I mean, it sticks out like a sore thumb. This is also more Mesnard. Here you can see some sedimentary primary structures like ripple marks. So we know this protolith or parent rock was a sandstone, and it's almost all quartz sand. And lower grade metamorphic because we are in that chlorite zone. So we still have preserved primary structures. And you can see it's deeply bedding here. You don't get ripple marks deposited on vertical cliffs. So obviously it was deformed later. This is the old Harvey Quarry. I'm going to talk about this a little bit. It's been up for sale for years now. And if I had the money, I'd totally purchase it. But here we have Huronian supergroup with older rocks and a shear zone in the area. This is a panoramic of Harvey Quarry looking west. So there's north, and these are your Huronian rocks. This right here is a diamictite. So it's glacial. It's oldest. It's equivalent to the Fern Creek and part of the Gowgonda in Ontario. It's glacial deposits. Now here's a map of Harvey Quarry. And as you can see, here's your legend for the units that you see here, and I've colored it. We have a dipping, plunging syncline that plunges into Lake Superior here. This is a nice rest area. It's a pretty big building. And here you can see this is that diamictite. Here's older rock. Carp River shear zone is right here. Shear zones are similar to faults in the fact that movement has occurred, except faults are brittle deformation. This is ductile. Here we have the contact between the Jacobsville and the Mesnard, which is that Paleoproterozoic rock. So what we have here is a huge, massive unconformity within the Precambrian. Remember, the Jacobsville is Neoproterozoic, so 980 million years old or so. The Mesnard, remember what I said? It's about 2,350 million years old. So we're talking an unconformity completely within the Precambrian of about 1,350 million years. So 1.35 billion years. It's a huge amount of missing time. And it's all right here. And you can see the Mesnard is more vertical here. The Jacobsville does dip slightly, but it's more level. So that's what we call an angular unconformity. Now, this actual contact is covered, but it is right around here. This part is just down here. And in other places, you have intrusive dikes, diabases, basalts, mafic intrusions, stuff like that. Now, I think I'm just going to wrap it up right here for you. This isn't all of the stuff from the Marquette area, but it's a lot of it. And I just wanted to show you how the book is laid out and stuff like that. I'll link it in the description for you. And the geology of the Marquette area is just amazing. It's a geologic wonderland, especially if you're a Precambrian geologist. You have things here like complex structures, synclines. There's a few anticlines. I think they're outside of city limits, though. Shear zones, faults, massive great unconformities within the Precambrian, stuff like that. Anyway, that's it. If you have any questions or comments, please leave them below, and I hope you learned something.